Hey folks, I want to continue on our test equipment section in our module 3. This one's going to be more on oscilloscopes and grafting meters. Now, this is where it gets to be fun, and it's these grafting meters and these oscilloscopes are going to help you a lot. Now, granted, some of the oscilloscope and DSOs actually are incorporated in some of your scan tools, some of your higher end scan tools, and you may not, need to have a full-on DSO. I recommend you do because with a DSO you can capture a whole lot more information. But I'm going to give you an overview of it, and later on in the week I'm going to kind of break it down a little bit farther and kind of give you a little more about the oscilloscope. If you're, that way it might help you with your diagnostic routines. Because believe me, when it comes to diagnosing a strange or a unique problem, an oscilloscope is going to help you. Anyways, let's go ahead and get started with that. All right, let's see, we're right here and share it there. All right, so like I said, we're going to start getting into oscilloscopes and kind of getting into oscilloscopes and grafting meters. This is on chapter 43. Now, this is an oscilloscope screen, and depending on how many scales you have on your screen is how you can actually divide it up. So this one has 1, 2, 3, 4, 5, 6, 7, 8. This is a 8 by, I believe, 10 a divisions, and they call them little divisions. And I can divide it up on my scopes that allow me to do it. Some of the scopes you get, you're going to just program what the sensor is. It's going to automatically set it up for you. But one of the things I've used these before, but one of the things I'm kind of not a fan of is because if I want to do something unique, let's say I have an oxygen sensor signal and it gives me a nice picture, but now I want to kind of blow it up a little bit. Some of them, these scan tools or the oscilloscopes that are programmable won't allow you to do that. They only say, oh, here's a picture, but maybe I want to look at rise time or something like that. I can't do it. Whereas you have an oscilloscope that has these capabilities, it's going to help you a little bit more. Now, I come back from the old time when we just had analog oscilloscopes, and we didn't have the digital sampling oscilloscopes that we have today, which are really helpful because you can record, you can play it back, and look for that little glitch as you go along. Whereas you had the old analogs that didn't have record features on it, you just had to be very quick. Okay, let's go ahead and try it again. Whereas before I can actually go, okay, now this is where that hiccup was. This is just kind of showing you some of the divisions. This is one showing a 1 volt division here by, let's see, now we've got a full second, or we can, this is giving you divide up. I can actually divide it up from anywhere from 500 milliseconds all up to a second. This is kind of give me that kind of divisions where I can actually do what I want with it and can kind of manipulate it a bit. These are kind of some of the divisions that I can do on the time sequence. So one of the things I want to go back and I wanted to kind of introduce you to whoops, I went to the wrong way. I went this way. Okay, so one of the things I want to let you know is the oscilloscope is just a fancy voltmeter in a way. It measures voltage just like your voltmeter would, but the other part it does, it actually gives you some, the time sequence. It gives you, when it maps out or puts a picture of, it actually shows you what exactly is happening with time. And a lot of times we look at that to make sure, and we do comparisons to good known oscilloscope patterns, and this is going to help you diagnose it a little bit. And there's some definitely unique signatures for different types of sensors out there that you have to kind of get used to. And you can't again know all of them. There's a big library online of different patterns for different types of sensors and different makes and models and colors. And here's an example here of a throttle position sensor. Just 5 volt, standard old type throttle precision sensor using the oscilloscope. But I could do this with a voltmeter, but look at, I can actually get a visual on this, and it can actually see if there's any kind of imperfections going up. Now, please don't think that this is bad. I'm not saying it's bad or good. I'm just saying it's a normal sweep going on here. And as it rose up, so I started up about a half a volt, went up to about 4.5 volts, and that kind of gave my full spectrum, and it dropped on up. So that looks pretty good. Now I could actually go farther in this. If I had an oscilloscope that could actually kind of spread it out a bit, give myself a little less time, I can actually show that picture and it looks a little bit more precisely. This is a great thing about oscilloscopes. Here's an actual showing an actual AC voltage, very common on some of your speed sensors. And this is showing a full cycle. Now notice it's not positive only, it's a negative and positive. This is actually showing a peak-to-peak voltage, and peak by peak, I mean by how high did it actually go positive and how low did it go negative. So that would, depending on what the measurement what is here. So this is showing a 0.707 times the peak. So this is just showing how I figure that out. And my cycle, how much that cycle went across, and then there's the upper cycle too. So our full cycle would be the two up and down going into it. And depending on how high the voltage went, so let's just say, for instance, it was 6 volts, and it went -6 volts. That shows me a peak-to-peak of 12 volts. This is another one. This is showing an actual alternator, a oscilloscope pattern. This is actually a normal pattern for charging voltage. It does have a little bit of drop off. I might be suspicious of it here, but this is a center line. So as we know, alternators, and if you don't know, alternators actually charge AC current, but we just go through a rectifying bridge or a diode trio, and we rectify the voltage to DC. And it's through a process through a part that's inside the alternator or in a regulator type that actually does that for us. We'll charge AC, get better amperage and kind of current coming through. Then we can actually rectify it to charge up our battery. If we have a leaking diode, we can actually have an actual an AC signal, which looks very kind of suspect right here. And we may have on this one a leaking diode right here. But if you notice these peak to peak going on here, this is about normal. If you were to actually look at a charging voltage, okay, and if you were to kind of stretch it out, on your oscilloscope, you're not going to see a nice straight line going across. You're going to see this kind of rippling going on. This is normal. You just got to watch out for the downward ripples. Here is actually showing an actual pulse, a digital type signal. We use these for different types of, sensors, and I should say different types of sensors put these out. This is actually showing frequency. How often does it rise and fall? How often does it stretch between on the next one down? So on time, off time. So my on time, it pulled to 0 here, and it became off time up here. Whereas these are kind of equal across. This is just showing frequency, how often, okay? And as we accelerate, it kind of squishes a little bit more back and forth. Here we're actually showing a duty cycle, and then we actually kind of do a little bit different here. We're actually going into pulse width. With the pulse width, we're actually looking at that width of that actually pulse and for that actual time sequence. Here is actually showing, a scope, versus a meter here. I'm seeing a, let's see right here, percentage of an 82.4, and this could actually be representing that 82.4. Okay, so this is off time on this particular one, because you remember whenever we go up, it's going to be off. Where it's going down, it's actually turned on. Here we're actually showing device opening and closing using the ground. So grounding it here. And here we're actually showing an off. Here's actually showing two-channel lab scope, and this is fun because we can actually show relationships between two cell sensors. This example, and I'll bring this up again. We want to look at a crankshaft sensor and a camshaft sensor and see if the relationship is correct. Because we do know that camshaft and the crankshaft sensor, there's a definite relationship between the two to make that engine actually run. Here I'm actually showing a symbol and it can actually rise and fall. So we use this on our trigger. I'll get more into the triggers as I go on the rest of the week here. Here's actually showing voltage on a battery constant. So this looks like what has happened here. Okay, the vehicle had started up. Here we are actually at rest, and then we started with the voltage pulled down, and then now we're going back up by the charging system here. And like I said before, some of these I should say, some of the manufacturers actually make a graphing meter, but sometimes they'll actually have features where you can actually program, okay, I want to test a oxygen sensor off of a 2012 Mitsubishi or something like that, and it'll actually set it all up for you, which is okay. It just when you want to do those unique things, sometimes you have to manipulate it a bit. Sometimes I'll put it in the most magnified part if I can, and then kind of zoom out to get my picture the way I want it. Or depending on the meter I have, I may leave it out and be able to zoom it on in. Some of the different flukes you can do unique things with to their actual one, which I'll be showing you this week of the actual going through this setting up features to get different good pictures to it. And then there's other different types of lab scopes you can actually connect to your laptop, and some of these Pico type scopes you can actually connect right into your laptop, which is great because if you want to make up your own library of unique patterns or known good patterns, you can have it in there. That way you can actually compare across, and which is kind of cool too. All right, so this is a little bit about lab scopes and some grafting meters, and hopefully this was helpful. And what I'll be doing is I'm going to be cutting some more videos later on the week. These are the first ones for tonight, and then I'll continue on. There's quite a bit that I want to cover, and as we get into the last part of the semester, I'm going to be kind of getting this all put together. So we'll start using some critical thinking skills. You're going to use all the tools that we've been teaching you along the semester, all the tasks that you've been doing through the semester, and we're going to try to get you to use this guy as much as you're doing this guy here too. All right. So again, if you have any questions, please feel free to reach out to me or Mr. Ingreson through the inbox. That's the best way, folks. I hate to keep on saying that, but that's the best way. That way, Mr. Ingreson and I both get the message. If you email me direct and it's really a question that you need for Mr. Ingreson, then I have to relay it across. Mr. Ingreson does not share my email address, and I don't share his. So that's the best way, kind of get over there and do that. And also, if it's a general question, feel free to talk to your classmates. And you can do that right through the discussion board. Again, right through the discussion board, where there's a discussion group when you go to the student lounge, and you can ask questions right there too. All right. Take care, and I will see you the next time I cut another video for you. All right, take care now. Bye.